So let's talk about some of the things that you should consider when working with SQL Azure. Things like application connectivity. How are you connect? What do you need to do when you're connecting? Compatibility, meaning what works with on-premise SQL Server and does that work with SQL Azure? Things like data types or all the data types supported and things like that. We'll talk about migration, meaning how do I get my local SQL Server database up into SQL Azure and the different ways you can do that. We'll talk about administration and security. How do I do the same roles and users that I have on-premise? Can I set those up in SQL Azure? We'll talk about price, size, and addition. We won't cover that a whole lot because we talked about that previously. We'll talk about code near versus code far versus hybrid approach, meaning we run into a lot of customers who think, hey, do I have to take and put all my stuff into Azure, including my application and database? So what's the right way to move to Azure? We'll talk about partitioning, sharding, and federation and what's coming out with that from a scalability perspective. And then we'll talk about backup and replication scenarios and what's available in SQL Azure. Let's start first by talking about how to connect with SQL Azure. We took a look at the connection strings in our Windows Azure Management Portal, and it's simply SQL Azure connection strings follow the normal SQL syntax. We saw that in the connection strings, right? You pull it up and you specify the server name and the username and different options. Then this allows applications to connect directly to a database. It's very simple, so there's not a whole lot of changes than what you're used to in connecting to a SQL database now. You do need to specify the initial catalog in the connection string. There is a difference in that there's no support for context switching, meaning there's no support for the use command. So I can't say in a query window or in a dynamic SQL use database. And that's because if you think about it and think about the way SQL Azure is architected, if I create one database, that database may go into one server in one container on one end of the data center. And if I create a second database, that database may be created in another container on another server on the other side of the database. And because of the way it's architected and you're going through the TDS endpoint, you really can't do context switching to say use database because one database doesn't know where the other database is. So again, this is a paradigm shift, and we have to now think about this in terms of the Azure platform. Some commands also must be in their own batch. For example, create alter database and create alter drop login, as well as create alter user with the for or from login. These must be included in the same batch. From an encryption security perspective, and we saw this in the demo connection strings in the Windows Azure portal, we must set encrypt equal true. Only SSL connections are supported. And we must include the set trust server certificate equals false option, and you also saw that in the connection string. This is there to prevent the man-in-the-middle type attacks. Now, the format of the username and server name for authentication is critical, meaning for ADO.NET, it's data source equals server.database.windows.net, and the user ID equals user at server name. Now, the server name does not need to be the whole server.database.windows.net. It just needs to be user at server. So the username and server name must be in these formats in order to connect to SQL Azure, either through SQL Server Management Studio or specifically the application. Now, it doesn't matter if you've got your security set up. It doesn't matter if your connection string is all ready to go. It doesn't matter if you have everything right. If you have not set up your firewalls first, you will never be able to connect. If you're running and testing and you can't connect, the first thing to do is go look at your firewall rules, because you could have everything ready to go, but if you haven't specified your firewall rules, you'll never be able to connect. We talked about firewall rules a minute ago. These are IP address-based access control for SQL Azure. There is no default IP address that is authorized to connect, so if you haven't specified anything, you can't connect. They are configurable using the SQL Azure portal. And you do have the option to disable and enable access from applications hosted in Windows Azure. So you can enable and disable these from applications that are hosted within Windows Azure. So in essence, you have the internet. And you have the SQL Azure firewall. All connections go through that firewall, even from Windows Azure. If you haven't defined your SQL Azure firewall rules, you're not getting in. Now, rather than using a REST API like the other Azure storage services, we talked about how SQL Azure is accessed via the tabular data stream, And this same protocol is used by Microsoft SQL Server, and this operates over port TCP 1433. So there may be the instances where you have specified a SQL Azure firewall rule with your specific IP address. If port 1433 has not been opened on your corporate firewall, then you still will be able to get in. Again, it's standard SQL Server port 1433, so that port must be opened for you to gain access to SQL Azure, even if you have defined a SQL Azure firewall rule. Let's talk about the SQL Azure compatibility. What's the same in local SQL Server on-premise versus SQL Azure? So what's currently supported in SQL Azure? Tables, indexes, and views, store procedures, triggers, constraints, table variables, and session temp tables. That's all supported. There is support for the spatial data types and hierarchy ID and the XML data type. What's not supported? Some data types are not supported, such as sparse columns and file streams. Partitions are not supported. Right now, full text indexes are not supported. The SQL CLR is currently not supported. Now, that's kind of a yes and no supported, because really the spatial data type and the hierarchy ID and the XML data type, those are actually CLR data types, but those are supported. What they're talking about here is if you were to create a SQL CLR managed code, for example, a SQL CLR store procedure or function, and import that into SQL Server, that's not supported or currently not supported. Any table that you create in SQL Azure does require a clustered index, but this is true and not true at the same time. So you can actually create a table in SQL Azure without a clustered index, but the moment you try to put data in that table, will generate an error saying all SQL Azure tables require a clustered index. It will actually let you create the table, but the minute you try to put data in it, you'll get the error. So in essence, that statement is true. Tables do require clustered indexes. So let's talk about some of the similarities and differences between the SQL Server and SQL Azure security capabilities. So you have traditional SQL Server versus SQL Azure. So for many aspects, for on-premise SQL Server, you do get SQL native and Windows integrated authentication. You can do authorization based on database users and roles. You can create server roles such as server admin, security admin, and DB creator. So if you know SQL Server, you've worked with this and you know this. Obviously, you can access SQL Server via TDS and SSL on port 1433. You can do firewall and IP blocking using the host firewall. And there is obviously on-premise support for native encryption through the TDE. So how does this translate to SQL Azure? Well, there is standard SQL Server or native authentication, but right now there is no Windows authentication. So for authenticating to SQL Azure, it's SQL authentication only, not Windows authentication. However, the role and user security is the same as is on-premise, so there is authorization based on database users and roles. You can add logins. So through the Login Manager, you do get the Login Manager and the DB Manager roles in the master database to simulate relevant server roles. So there's a small change there. From an access standpoint, it is via TDS and SSL on port 1433. There is native SQL Azure Firewall for IP blocking, so there's some similarities there as well. However, there is no native encryption support, so there is no TDE support yet. And they are working on this, but for right now, as of the time of this recording, there is no native encryption support. Let's talk a little bit about the Login Manager a little bit more. SQL Azure has a Login Manager role for creating logins and DB Manager role for creating and managing databases. However, these roles can only be assigned to users in the master database. So SQL Server uses the same familiar and proven authentication and authorization model used by Microsoft SQL Server. Many databases contain sensitive data, so it is essential to carefully control access. And this is especially important in a multi-tenant application that involves users from different customers who must be isolated from each other. SQL Server does provide the same set of security principles that are available in SQL Server with SQL Server authentication, and you can use these to authorize access and secure your data. So from a SQL Server logins perspective, these are used to authenticate access at the server level. You do have database users, and these are used to grant access at the database level, and then database roles, which are used to group users and grant access to SQL Azure at the database level. So managing security at the database level in SQL Azure is almost identical to Microsoft SQL Server, with differences only in the parameters available. The database level permission model in SQL Azure is the same as on-premise instance of SQL Server, meaning logins associated to users in the database. Users may be part of one or more database roles, and permissions can be granted to roles or directly to users. Currently, however, auditing features are not supported in the current version of SQL Azure. And we talked about this. SQL Azure does not currently support the TDE protocol, and TDE actually stands for Transparent Data Encryption. SQL Azure does force SSL encryption with all client connections, and thus data is secured over the wire. When defining the connection string to SQL Azure, developers should use the following parameters, and we talked about this earlier. Encrypt equals true, which specifies that SSL must be used in the connection, and trust server certificate, which specifies whether encryption occurs if there is no verifiable server certificate. Setting the value to false forces the client to verify the validity of the certificate presented by SQL Azure. So let's talk about some of the migration options about how to get your local on-premise SQL Server database into SQL Azure. And there really are several options that you have. The first one being the Generate Script Wizard, which is built into the SQL Server Management Studio. And this simply produces a script that is compatible with SQL Azure. Now, this compatibility only works, and this option is only available in SQL Server 2008 R2, but not available in early versions, meaning it's not available in SQL Server 2008 or 2005. You do have the SQL Server Migration Assistants, and these are downloadable from the MSDN website. And these migration assistants do provide the ability to migrate from MySQL, Oracle, Access, SQL Server, and things like that. Again, these can be found on the MSDN website. You do have the SQL Azure Migration Wizard, and this is a CodePlex product. And this is useful for catching unsupported features in SQL Azure. And is a nice way to move your data efficiently from between on-premise and SQL Azure. Now, because this is a CodePlex product, it is not officially supported by Microsoft. And then you have the Data Tier Application Component, commonly called DAC. What it allows you to do, it actually allows you to take your database and package that up into an install and then run that install on SQL Azure. So it does support the install and uninstall. It contains the developer intent as policies. Now, what's not listed on this screen are two more options. You can use SQL Server Integration Services. You can create a package which will migrate your database from on-premise to SQL Azure. The downside, or one of the limitations of SQL Server Integration Services, is that it does not do the schema. You can't script the schema. But it does create great functionality for exporting and importing your data from on-premise to SQL Azure. So there really are several options for migrating your database from on-premise to SQL Azure. Now, just as a FYI, there are some pros and cons to some of these. For example, the Generate Script Wizard. If you have a large database and you're scripting the entire schema and data, well, then that script can be quite large. In fact, if you have several hundred tables with stored procedures and data and other things, you might be working with a script that's several hundreds of thousands of lines of code long. Can become unmanageable. So really, from a Generate Script Wizard, just as an FYI, be cognizant that you might be working with a very large script. The SQL Azure Migration Wizard really now does what the Generate Script Wizard does, so it's a pick your type of thing. And they both really do the same thing, although the downside is that the SQL Azure Migration Wizard is not officially supported by Microsoft. But you do have several other options. I'm a fan of SQL Server Integration Services because it runs real quick. You can script out your schema, include that in the task, and it'll run in just a few minutes, really depending on the size of your database and how big it is. So again, you do have several options, and there are some things to consider. But let's stop here and let's take a look at some of these options in a demo. In this example, I'm going to illustrate how to migrate an on-premise SQL Server database to SQL Azure. Now, I'm not going to migrate the entire database. I'm going to pick a simple table, and using the Generate Script Wizard out of SQL Server Management Studio, I'm going to pick a simple database, script that, and use that to create a table in SQL Azure. Now this demo is really in three pieces. The first piece is to take that table, script it, and run that script into SQL Azure. And the first piece is really to illustrate two things: how to script and run in SQL Azure, and two, what things to look at and to consider as part of the process of moving and scripting a database object from on-premise into SQL Azure. Part 2 of this demo is then going to use SQL Server Integration Services to migrate the data for that table from on-premise to SQL Azure. And then part 3 of this demo is going to create a very simple Visual Studio application to connect to my SQL Azure database, and specifically to that table, and pull data out of SQL Azure and display that on my form. So let's begin with part 1, which is to script a specific table out of a database and then run that script in SQL Azure. So for that, let's fire up SQL Server Management Studio, and let's connect to our local database. And one of the local databases that I have is the AdventureWorks database. You can get this database from Codeplex, and they have a number of sample databases that you can play with. So I'm going to right mouse click on the AdventureWorks database. I'm going to select Tasks, and then I'm going to select Generate Scripts. So on the introduction screen, I'll click Next. Now the default option on the Choose Objects page is to script the entire database, and we really don't want to do that because that'll be a really big script. And specifically, we're going to select a specific table. So I'm going to select a specific database object, which is a table. So I'm going to expand the table node and then select the person.contact table. Click Next. And on the set scripting options, this is where we need to focus our attention really, because a lot of the options that we want to focus on are on this page. The first thing I need to do is select to save to a new query window. Then I need to select the Advanced button, and on the Advanced Scripting Options page is where I really need to make some changes. For this example, I'm not going to make any changes, but I want to point some things out on this page. So the two things I want to point out are the script for server version and script for the database engine type. With SQL Server 2008 R2, I have the option to script for a standalone instance or a SQL Azure database. Now, one of the things I also want to point out is if I were to select, for example, SQL Server 2008, for example, I still have the option to script for a SQL Azure database, but notice what it does. If I select that option, it will change this back to SQL Server 2008 R2. But for this example, I want to select standalone instance because I want to point out what happens if I script for a standalone instance and then try to run that script in SQL Azure. So I'm going to script for SQL Server 2008 R2, click OK, click Next, and let it create the script. It's all done. There's my script. And what I'm going to do for this script, for simplicity, I'm going to get rid of all the extended property objects. All I'm interested in for this demo is the table. Okay, let's get rid of this window. We don't need that. Now, I've created my script. Now what I want to do is connect to my instance of SQL Azure. So let's open up our management portal for Windows Azure and make sure that my firewall rule is set. So I've got that good to go. So let's connect to our instance of SQL Azure, and we've already got the database selected. Now remember, for SQL Azure, we do need to connect and use SQL Server authentication. So I'm going to enter my password and click Connect. I've connected. And what I'm going to do is I'm going to run, let's pick our AppDev2 database. There's no tables in there. So let's create a new query window for that. And let's copy this code, this create table statement, from our local query window, from our query window that's pointed to our local instance, to our query window that is pointed to our SQL Azure instance. Okay, before we get going, obviously the use statement isn't supported, so we're going to get rid of that. And there's a couple things that we need to fix here before we can run it. So obviously we know that the for replication is not supported. We learned about that earlier. There's a couple other things that we need to fix, only because not that they're not supported, but we haven't run, since this is a new database, we haven't created the objects that this is going to be using. For example, there's no such thing as a name style object or a .name object. So I'm going to actually remove the name style column, and then I'm going to change the let me go up here and copy this. And one of the things I'm going to do is I'm going to change anything with the dbo.name to varchar 100 just to make sure we have enough. And this is for first name, middle name, and last name. And we're good there, we're good there, we're good there. We also do not have a phone type. So I'm just going to make that varchar and varchar 25. The only thing I fixed right now is I removed the not for replication because we know that's not supported. And we fixed a couple other things that, although they are supported, the object just isn't created for like defaults and things like that. Okay, so if we were to run this, the question is, would it work? Would it actually create the table in Azure? But before we test that, there's one other thing. The person portion here is a schema, and the schema exists on the on-premise database but does not exist on the SQL Azure, so we're going to get rid of that because that's an unnecessary error we'll get. Let's run this and see what happens. Okay, so we get an error that says keyword or statement option content is not supported. So that's because if we look down here, although the XML data type is not supported, it's referencing a schema that we have not created. So let's get rid of that. Okay, let's try this again and see if it works. All right, the pad index is not supported. So let's get rid of that. And we also know, since we're fixing this section down here, we also know that the on-primary is not supported because the on-primary statement is referencing the primary file group. And in the Azure platform, we don't have access to any of the hardware to create file groups and additional file groups. So the on-primary statement is not supported, so we need to remove that one. We need to remove this one at the end of this statement. And we know that the pad index is not supported, as the error statement tells us. So we're ready to go. Let's see if this works. We'll run this. Okay, now we know that the allow row locks is not supported. So I'll save some time and also tell you that allow page locks is not supported. So let's get rid of those. All right, let's see if this runs. Now it's telling us that the row good column is not supported. So let's just get rid of that column altogether. So let's run this. And that worked. So through this example, we showed what types of things are not supported in SQL Azure. And I'll actually bring up a website from the MSDN website that shows and presents a look of what things are really supported and what's not supported. So we've got our table created, so let's go and refresh our table list. There we go. So there's our table, and there's the columns. So this is a simple exercise that shows how to migrate a simple object from on-premise SQL to SQL Azure. I would highly recommend that you take one of your local on-premise databases, use the generate script wizard, script a few objects such as tables and store procedures and functions and things like that, and see what kind of errors you get when you run this in Azure, because it's a good exercise to help you understand what's supported and what's not supported in SQL Azure. Okay, so we have our table supported. We're all ready to go. This was part one, taking an object in on-premise SQL and moving that to SQL Azure. Let's go to part two now and use SQL Server integration services to migrate the data for this contact table from on-premise to SQL Azure. So let's minimize this. And to get to SQL Server integration services, we're going to go to All Programs, go to our SQL Server 2008 R2 folder, and we're going to start the SQL Server Business Intelligence Development Studio that is installed as part of SQL Server. We'll fire that up. Let's maximize that. And in this, we're just going to create a new project. So we're going to click the Create option. And the project type that we want to create is an integration services project. And let's call this Move Contact Data. Let's click OK. if you're not familiar with SQL Server Integration Services, that's okay. I will explain things as I go along. This certainly isn't a full demonstration on all the aspects of SQL Server Integration Services, but what we have here is a package. This is a SQL Server Integration Services package. It has a control flow and a data flow, event handlers and package explorer. We're going to use the control flow and data flow, and we're not going to get very complicated because on a control flow, we're simply going to drop a data flow task. And on this data flow task, we're simply going to double click, which takes us to the data flow tab. Now on the data flow tab, we want to do two things. We want to drop a ADO.NET source task, and we want to drop a ADO.NET destination task. Okay? Now, we need to tell the package where the source of our data is and where the destination is. So to do that, we need to come down to the bottom in our Connection Manager section and create two connection managers. New ADO.NET connections, and the first one we're going to create is to our local SQL Server instance. So let's click the drop-down box, and we'll pick, let's go back, let's get the name from here. Well, we can actually just say local. Instead of picking it from the list, we'll use Windows Authentication, and let's pick our AdventureWorks database, and let's test our connection. Test connection succeeded, so we're good to go. We'll click OK and click OK there. So there's our local one. Now let's create a new ADO.NET connection. New connection. And this one's going to be to our SQL Azure instance. So actually, let's grab that and make it, copy that from this dialog, just to make it easy. So that's that. We are going to use SQL Server Authentication, and that is, again, we're going to cheat, grab the name, app-dev-admin, the password, and then we're going to, I think it's app-dev2, test the connection. Test connection succeeded, so there we go. Now, in a previous discussion, we said that the username must be in a format of app-dev-admin or username @ and then the server name. So if we were to copy this up here and put this here, this works in SQL Server Integration Services. This works as well. But you can also, for SQL Server Integration Services, keep it at that. So we'll test our connection again, make sure it succeeds. Yep, it succeeds. Click OK. And click OK. So now we have our two connections to the two sources. However, we need to tell it where to get the data. So we need to configure each task. And this is our source task. So our source is our local instance. So we're going to double click this, pick the right connection, so it's our local AdventureWorks. It is a table, and we're going to go to the person.contact table. There we go. There's the columns that we're going to get, and then click OK. Simple as that. We need to configure this one as well, the destination. But before we do that, we're going to grab the green arrow and drag it down to the destination. This is a flow, meaning it's going to start here, and once that task is done, it's going to go and execute the destination task. So let's double click this to configure that. We want our destination not to go to our local box, but we want it to go to our cloud database. It is a table or view, and it did pull up our contact table. Now we need to tell it, we need to map the source column to the destination column. And SQL Server Integration Services is actually pretty smart about this. So if we click the mappings page, it actually mapped the columns for us. So you recognize, or you'll see that we removed the name style from our destination, so there's no mapping there. And we also removed a couple other columns, like the row good column, so there's no mapping there. So it actually mapped the columns that we want it to map, and if we want it more detailed, we can go down to the bottom section here and see what columns are actually mapped. So we're done. We can actually click OK, and there you have it. So our package is created. We can actually run this. Let's save it. And now we can actually run this and have it move the data from our on-premise contact table to our SQL Azure contact table. The way to do that is you just go up to the green right arrow and click the Start Debugging. Let's get rid of these so we can see a little more view. You'll see that the tasks that are being processed are in yellow, and you'll see the number of rows that it's actually moving. When the tasks are done and successfully executed, they turn green. So now we see that it's moved almost 20,000 rows from our source on-premise database to our SQL Azure database. It's all done, so we can stop this. Let's go back to our SQL Server Management Studio, and in the same window for AppDev2, let's actually scroll down and do a select star from contact. There you go. There's all the rows from our SQL on-premise SQL Azure contact table that have been moved to our SQL Azure contact table. So that wraps up part 2 of this demo, which has been moving data from our on-premise database to our SQL Azure database. And that succeeded. So let's move on to part 3 of this demo. And that's to create a Visual Studio application that now pulls that data out of SQL Azure and displays it on a form. So let's fire up a new instance of Microsoft Visual Studio. And let's create a new project, and the project type we're going to create is a Windows form application, and we're going to call this SQL Azure Connection. Click OK. And here we have a blank form, and on this form we're going to place 2 controls. Just for simplicity reasons, we're going to drop a button and a list box. So there's our button, and there is our list box. Doesn't need to be too big. Okay. And let's do this. Let's make sure that the properties are the same. Let's save this. Let's make this what it's supposed to be, which is a pure .NET 4.0 project. And what we need to do is we've got that. All our references are correct. So let's go back to our form and let's start adding code to our form. We're not going to change the text of our button. However, let's double click our button. And we're just going to add code to the click of our button to pull data from our SQL Azure contact table and display it in the list box. What we do need to do, however, before we start adding code, is let's go down here and add one more using statement using system.data.SQL client, because we are going to be using the ADO.NET SQL client to access the SQL Azure. So anytime you're doing and accessing SQL Server using the ADO.NET, you do need to include a reference to the system.data.SQL client namespace. All right, we're ready to go. So here's the code we're going to add. So we're going to first define a connection string variable. So we'll just make it empty for right now. And then we're going to say this dot cursor, because we're loading again like 20,000 rows. So we want to put a cursor around that. Equals cursors dot wait cursor. Let's close that. Setting that when it's all done, we want to set that back to the default cursor. Now what we're going to do is we're going to say using the SQL connection. The SQL connection object is the ADO.NET object that allows us to make a connection to either SQL Server or, in this case, SQL Azure. So we're going to define that as con equals new SQL connection. And here we need to specify the connection string. Now we haven't filled in our connection string, but we will come back and do that in a minute. And then we're going to say, the next step is to say we're going to define a SQL command object equals new SQL command. And here we're just going to hard code a SQL statement. I'm going to say select first name, last name from contact, and then pass the connection for this command. The SQL command object is another ADO.NET class that allows us to actually execute a command through the specified connection. The command can be anything, but in this case, we're issuing a select statement for the first name and last name columns from our contact table in our Azure database. So then we can say, now we need to open the connection. So even though we've defined the connection, we haven't opened it yet. So we issue the open method on the connection. Then we're going to define a SQL data reader. Execute reader. We define the SQL data reader, which says go, and even though we go execute the command, it's going to be put in a SQL data reader that actually allows us to read the data that's coming back. So once we have the data, we're going to start looping through this data. And while we're looping through, what we're going to do is add the first name and last names to the list box. So we're going to use a string.format to do that. And the way we do this is we say, we're going to grab, the way we reference the columns is basically the reader and the columns in numerical order. There we go. And in this case, we're going to go back here and say, so first column, second column. Okay. Clean this up a little bit. All right, so there we have our code. So in essence, we're basically getting a connection string. Let's go get that right now. And that, remember, we showed you in the portal is simply by selecting the database and then going to the connection strings and grabbing the specific connection string that we want to work with. And in this case, ADO.NET. So we're going to copy that. Go back here and paste that in here. And what we do need to do is change the password. So we enter the password. So it's going to use this connection string to create a connection to our SQL Azure instance, issue the select statement against our contact table. It's going to pull this data, execute that statement, and then loop through that data, writing the first name and last name to the list box. So let's save that. Let's compile our project to make sure it compiles fine and there's no errors, so everything succeeded. So let's run that. Press F5. There's our box. So if we click the button, oh, we got an error, or nothing happened. So let's go back and debug this and figure out what happened. Oh, I know the problem. We need to go to the AppDev2 database. That's our problem. We picked the wrong database. And the reason being is because I created a second database, and we need to refresh our list here. So we actually have our Windows Azure portal has not refreshed because we have a Windows AppDev2 database that our table exists, but it has not refreshed. So it's actually AppDev2. So simply by changing that to AppDev2 should work. Let's make sure everything else is correct. Okay, so that should work now. Let's run that. Click OK. There we go. There's our data. So that actually went out to and made a connection to our SQL Azure database, queried our contact table for the first name and last name columns, all 20,000, brought those back, looped through those. It looks like I used the first name for both parameters, but look how fast that was. Even pulling back almost 20,000 rows, yet we're only pulling back 2 columns, but it was still pretty quick pulling data from a cloud database across the wire and displaying that in our form. So in this example, it was 3 parts. We first took our table from on-premise, scripted that, ran that in SQL Azure, looked to see what kind of corrections we needed to make to run that script in SQL Azure. Part 2 was to then use SQL Server integration services to migrate the data for that table from on-premise into SQL Azure. And then part 3 was to build this simple application which connected to our SQL Azure database, queried our contact table for our first name and last name, and displayed those results in our form.